This video is about how the Compose Compiler plugin does testing. This is one of my favorite videos because it goes into the APIs that the Kotlin compiler provides to do analysis to be able to convert FIR to IR. So what you'll see in the Compose Compiler plugin is test code, test composable code like this, and you'll see a lot of resource files that contain the expected generated code like this. And in the test, what the Compose Compiler plugin is able to do is to take this piece of code right here and feed it to all the transformers. In the end, you get an IR module fragment, and it's able to do assertions on it. And how does that work? So here's what a simple, typical test scaffolding looks like. You have the source code, which is defined in a string. It has to be converted into a virtual file, and then it has to be given to the front end of the compiler. How does that work? This works by utilizing a facade that's in the Compose Compiler plugin. And what this facade is provides an API to interact with the Kotlin compiler, and it takes in your source code, and it's able to take that and convert it to an IR, and that you could utilize in the end. And its API looks like this. It has an analyze method. It has a compile to IR method, which takes in all your test files. It has a front end method, and as the name suggests, it's utilizing the front end of the Kotlin compiler. So the first thing that you need to do to create this facade is to inject into it a configuration for your testing, which is what it does here. It turns on certain settings, as you can see. So the next thing that has to happen is that we need to take the source code and we need to create a virtual file. A virtual file is a utility provided by the Kotlin compiler, and what it does is that it takes your source code and for the Kotlin language, it creates a virtual file out of it. We could utilize this to then create a PSI tree that we could do analysis on. So how do we go from that source code, that virtual file, to this PSI tree? Well, there's a utility provided for it. There's a factory that you could use to do that, which is called PSI file factory like this. And there's a method that you could use, try set up PSI for a file. As you can see, I'm providing the virtual file right there. And what this does is that this is all happening in the front end of the compiler. These are APIs that I'm using to do this programmatically. So this right here, what it does is that creates a PSI. Then I need to do semantic analysis. I need to be able to determine whether does my test code have any syntax errors or not? How do I do that? I could tap into the analysis APIs. Something that the K2 compiler has, which has come a long way, that it has introduced an analysis API that you could use. And this has helped in, for example, adding Swift export support. So what does the analysis look like? Well, the analysis API allows me to provide a diagnostic reporter, and allows me to utilize that to get any errors, to aggregate them. So the Kotlin compiler has a method to do this, to do resolution, and it's called build resolve and check FIR. So to utilize this, I'm going to pass in my files to it, and I'm going to pass in a reporter. And the reporter is a type that I'm going to create. And what the Compose Compiler plugin does is that it aggregates any errors from all of the files, and it reports them. So what this contains is a base diagnostics collector, which is a type provided by the Kotlin compiler that you could use. And the way this works is that it goes through all of the PSI elements like this, and then it does an analysis on it, diagnostic on it for any errors that it provides, and then it aggregates them, and it errors out, doesn't go forward if there are any errors found. And so this is how the analysis API looks. So the next thing is that when you have your FIR, you want to be able to convert it to your backend IR. How do you do that? And there's a API provided to you to be able to do this. In the Kotlin compiler, you'll see that there's a CLI utility that allows you to do this. It's called JVM FIR to IR extensions. And in this case, you can see this is for the JVM. And so this is a utility that the Kotlin compiler provides, and that the way it uses it, this is how you configure it. This is how it gets configured in the Compose compiler plugin. And then what it's doing is that you can see there that it's taking my FIR, and it's also taking a specific reporter, and it's able to give me an IR module fragment in that result right there. So it's able to, what this does is that it's going to go through all of the transformers in my Compose compiler plugin. It's going to go through the IR, it's going to create an IR tree for it. And what this result type contains is that module fragment that then I could use to traverse that IR tree to do assertions. There is something called verifying golden rule, which is used inside of the Compose compiler plugin to do assertions you'll see in different types of tests. So this is a very brief snapshot of how testing is done, what the scaffolding for testing looks like in the Compose compiler plugin. So it is a bit advanced. So the benefit of understanding the Compose compiler plugin is that it allows you to see with an example how to use the IR builders that the Kotlin compiler gives you. It is a bit complicated at first, but once you get used to it, it starts to click. The tests are really helpful, and that's it.